modifying the basic data types. Beyond the 5 fundamental data types, C allows to modify the meaning of the data type. For example, we have a vehicle, but we cannot say how many person can sit in the vehicle. But whenever we say the car, people can understand 4 person can sit in the car. Similarly, whenever you say the motorbike, people can understand 2 person can sit in the vehicle. Similarly, the modifiers are helping to define the precision, size range, and signedness. With an exception of the void, all the basic types can be modified. Modifiers have following types: signed, unsigned, long, and short. Integer can be represented by all of these four. Character can be signed and unsigned. Double can be the long. In C99 and onwards, it is introduced to have the long integer. Data type size and range of these all are available in the table. Let's see the example and understand. In this example, we have defined one function to print the binary for particular data type. The program represents all the type of data type: character, integer, float, and double. As well as in the program, we have utilized all the type of type modifier as well. There are some inbuilt variables available such like schar minimum, schar maximum, etc. These variables are helping to see the range for particular data type with its type modifier. Other thing to note is we have utilized format specifier. However, we are going to cover the same topic in upcoming videos, and we have utilized the function to print the binary for particular variable. The same format is repeated for all the different type of the data type as well as with its type modifier. Let's try to run the program and see the output. You can see the output. By default, character is considered as a signed character. So the output for character A with its binary is represented here. Here we are storing the number value in the character. It is very much important to note that number must be within its range. In the character, the range specified here is -128 to 127. Hence, it will print the output properly. If we give the input higher than this range, then output will be a random. Let's try to run again and see the output. As you can see, the output is very random. As well as you can see there is a problem in our code and overflow in conversion. Hence, we must give the input in the specified range of a data type. So let's correct the program and run again. Similarly, by default, integer is considered as signed integer, and output for the integer numeric 5 is represented here. Whenever we are specifying the floating point, then it is not possible to assign any type of type modifier such as signed, unsigned, short, or long. Hence, float will remain as it is. For the double, default is not considered as a long double. The only difference between float and double is in the precision and accuracy. For the scientific calculations, we are majority time considering the double. The output for the double numeric 66.66 is represented here. Now let's see the type modifier as well. For the signed character, you can see the minimum value is considered as -128 and binary for the same is represented here. Now maximum value is considered as 127 and binary representation is here. For the unsigned character, the maximum value is represented here and binary for the same is here. For printing the size range, we have utilized the variable defined within the C, such as schar minimum, SCHAR maximum, unsigned character maximum. For the other type modifiers, such kind of variables available. For the short, you can see SHRT minimum, SHRT maximum, unsigned short maximum. Same way you can see for the integer as well. And for the long and long, such kind of variables are available. Also note that if we use this syntax is equivalent to defining long int. For example, the syntax long int abcd variable name is equal to some value is representing the same kind of output. However, we are using the first syntax. Same kind of syntax is available for long as well. Long is equivalent representation of long integer. Let's analyze the output by expanding our terminal. Here the most important thing to note is in the maximum numbers. So for short integer maximum and unshort integer maximum, you can see the higher bits are different. Apart from that, all the binaries are same. Same thing is observed in the signed and unsigned integer maximum. Similar things are available for the long and long integer. The binary representation remains same, only the first higher order bit is flipping. This observation gives us the concept for 2's complement, which helps to do arithmetic operation efficiently and effectively in the computers. Now let's try to understand 2's complement topic in detail. In our example, we have defined three numbers, two negative numbers, -50 and -51, and one positive number, 50. Now let's go to the binary representation for all these three numbers and let's see what is the conclusion. If we flip the binary for 50, then it will become exactly equivalent to the -51. So the key operation here is to add +1 in -51 gives us the correct result as a negative number for our purpose. Now let's try to understand few more topics from the documentation. Signed versus unsigned. For the signed integer, higher bit is representing sign flag. For example, 0 is representing the positive and 1 is representing the negative. Unsigned integers are using all bit as a positive integer. Now let's take the example for the binary using the short integer and let's see the output. In this example, we have considered two short integers and one unsigned short integer. Now let's try to run this example and see the output. In the output, you can clearly see the difference between two short integers. Only higher order bit is changed and difference between short integer and unsigned short integer is indicating that higher order bits are giving the higher range of values. Now let's go further with the document. The topic for 2's complement representation is already been seen with the example. Let's understand some of the note points. Whenever you are representing the integer, by default it is considered as a signed integer. Similar way, character is also important with the signed and unsigned use case depending upon the systems. And when modifier is used alone, integer is implied. For example, signed is equivalent to the signed integer. Unsigned is equivalent to unsigned integer. Long is equivalent to the long integer and short is equivalent to the short integer. For the floating points, these modifiers are not applicable. For engineering calculations, we are using the double to get more accuracy and precision value than float. But floats are effective for the faster calculation. From this, we learn that how the basic modifiers are working and we understand the difference between signed and unsigned integers. We can apply this modifier correctly to write a precise and portable program. And we also understand the interpretation for the binary for the 2's complement arithmetic. Thank you. Have a nice day.